Good morning. Today we are going to do a demonstration to show you that the berms that were built against the fence in the alley behind this home on lot 143 and 144 is not allowing storm runoff to flow out of the patio area into the alley, into the swale, to flow out into the street, as was designed and approved in the final grading plan that was approved by the City of La Quinta for the Watercolors at La Quinta Homeowners Association. And we hope this video shows you that this project was not done properly and can pose significant flooding risks to the home in this case, especially on lot 144, which is the home whose stucco wall you can see throughout this video. So here's what we did. We laid out an ordinary garden hose into the alley, you can see here, and we've turned it on, and we're going to see how well, if at all, the water flows out of the alley and into the swale. So the first step in calculating our storm runoff in the trench here and the goal of draining it out into the alley is to determine how much water is actually flowing out of this hose. So we use a standard garden hose flow rate calculator. The assumptions are 1/2-inch hose size. Hose supply pressure was measured at 45 psi. Our hose length is 50 feet. That gives us 9.2 gallons per minute coming out of this hose. So over the course of this 5-minute video, we'll see about 46 gallons of water flowing into the trench, which, if done correctly, would flow out through the opening in the fence and out into the swale in the alley. If we try to convert that into an approximate rainfall amount, we're estimating that this is the equivalent of about 1/10 of an inch of rain flowing off the roof into this trench, upwards possibly as high as 0.2 inches. And again, the position we're taking is that the buildup of the berm on the other side of that wooden fence that you see there is preventing storm runoff from running out of the alley. Running out of the trench here in the backyard of this patio home. We're just moving the camera around, but if you look, you really can't see any movement of water towards the back of that fence, towards the alley. It just is simply being blocked by that berm that was placed on the other side of this wooden fence. And we're hoping this video demonstrates that the drainage is simply not flowing as was designed, once again, by the design in the approved grading plan, the final grading plan for this community, Watercolors at La Quinta. Now we're not gonna let this hose run to the point where it starts putting the house in danger, but during a rainstorm event, this is a real possibility. In fact, we've measured the water capacity of this trench. It will only hold about 107 gallons. And we've measured the rainfall coming down off of this roof during an ordinary rainstorm event. And I encourage you to look at some of the other videos on this channel to see the surprising amount of water that actually ends up in this trench. By the way, the trench is about 30 feet long, a minimum of 14 inches wide, and a minimum of about 4 inches deep, which is basically code. And if you do the math, that has a capacity of about 107 gallons. So again, our message to you and to all that are listening, we need to fix the defect that is inherent in this current remediation project so that when rain falls onto this patio area, whether it's coming off of the roof of a home or it's falling directly onto the patio, we need to get the rain runoff to flow out into the alley, into the swale, and out into the street as was designed. Again, take a look at our other videos. Thanks for watching, and give us a call if you have any questions.